3.3 logarithm expressions. So log is just another way to write exponents. It has its uses in the future, but for now, just a very basic introduction to logs. The reason I put 2.2 and 2.3 together is because 2.2 has a lot of 3.2 has a lot of graphs. It's not that important. It really isn't. I'll talk real quick about that in a second. So, the idea with logs is this number, we call this your base. Let me just put a number here. Let's just say x. So, the idea of log is just, again, it's another way to rewrite the exponents. What this means, this is the same as b, the base b, to the x power is equal to a. That's all it means. It's start from the base, hit the x, and then come back to the a. Shortcut to write it. That's all it is. Okay? So, for example, you can go the other way. So, let's write this in actual real numbers. You know that 2 to the third power is equal to 8. Right? 2 to the third power is 8. This can be rewritten as log base 2 of 8 is equal to 3. It's exactly the same thing. Okay. So then sometimes when the base and this number are the same, I actually don't remember what this number is called. When they're the same, this is equal to 1. And it makes sense, because let me use this example again. Let's say if I just put 2's in here. So this will say 2 to the first power is equal to 2. And you can put any number in there. You can put 8. 8 to the first power is equal to 8. It's all the same, right? So when the base and that number is the same, it's always equal to 1. So the a log graph just goes like that. All right, it starts here and it hits it and it just kind of curves out. So there's a special case. Remember the last time we talked about the base e? That's your natural base. So log base e. Let's say log base e of x. Sometimes I'll write it in a parentheses, sometimes I won't. Log base e of x is the same thing as the natural log of x. This is just that. So in the future we don't write logs anymore. Natural log is just so much easier to write. One less letter. You don't have to deal with the base. So that's in the future you can see a lot of that instead. So similarly, log base e of e, which is the same thing as the natural log of e, is equal to 1. Okay, these two you can kind of think about how they reduce. Technically, they don't reduce, but you can think about it that way, and they will become 1. Okay, and then quickly, well, log base e just looks very similar. It's a little bit higher, just like that. If we don't write any base, then it's a base 10. Here's what I'm talking about. So if you look at this problem, this is a base 4. If I just write a log 25, that's a base 10. Okay? You don't have to write that 10. The 10 is kind of given. The reason why is a long time ago, before your calculators can really do logs, you have to use this change of base to turn everything to base 10. So if you were to take this one, the formula says if you want to turn anything to base 10, you just need to divide them. So this says log of a, put that on the bottom, and the x is on top. So this is the same thing as log base 10. I don't need to write it. 25 divided by log base 10 of 4. And again, you don't even need to say the 10. You just say log of 4. And then it's not wrong. You can put these in parentheses if you want. You don't have to put them in parentheses. I'll show you when you should use parentheses in a bit. All right, put this in a calculator. Just give you a random decimal number. That's why we don't. It's not that important anymore because now your calculator is so good at doing it. And then this one, log 125 divided by log of 5, and then this one is equal to 3. I just know that's equal to 3. And then lastly, change of base to base e. So, same idea. This is equal to log or natural log of 3 divided by natural log of 5. Put that in a calculator, you get some weird decimal. And then lastly, the natural log of 6 divided by natural log of 9. Get some weird number. Okay. And then a quick thing to note, natural log of 1 or natural log of 0 does not exist. Same thing with the log of 0, because anything to the something power can never get you to 0. Yeah. So, again, that's quick. This is the more important part. There's a couple of rules of logs. They're actually pretty simple. The product rule is, we call it expanding. The idea is if I take a log with two things or something being multiplied, how can I rewrite this? So if there are two things in here, that means I'm going to have two sets of logs if I'm expanding. They're being added, therefore, or they're being multiplied, therefore they're being added. And then each one just gets their own. And I'm just writing really big so that you can, I'm trying to emphasize where the U and the V are coming from. But that's really it. If they are being divided, then you just simply subtract them. And then lastly, the power rule. The power rule says you can take the exponent and you can move it to the front. So this is really n log a of u. Okay. And then the natural log is exactly the same. It's just that instead of log, you have natural log. Right? And same here. It's just that now it's a subtraction. And same here where you can move the exponent to the front. So this is n natural log of u. Okay, so let me actually show you how it works in your homework. So the book likes to do all these weird things. I like to keep it simple. When you're expanding, so make sure you know what you're doing. Expanding. Expanding means I need to make it longer. So I need to identify how many pieces are in this log. So these are the things that's being multiplied together. So I have 1, 2, 3 things being multiplied together. 3 things, that means I will have 3 set of logs. They each get their own. I have my 5, I have my x to the third power, and I have my y. Since they're being multiplied, they're added, right? So my rule is if it's on the top, it's added. If it's on the bottom, it's a subtraction, right? These technically are all on the top, so they're all being added. And then lastly, you can be lazy like me if you want. I just like to draw this 3, and I just like to put it right there and cross that out. And let me know that I brought that 3 to the front. And then you're done. All right, so recap. how many pieces do we have? We have 3 pieces in here. So they each get their own log, and then don't forget to bring the exponent to the front. Not to the front of everything, but to the front of the log that it's impacted. Look at B. So again, we're expanding. How many pieces do we have? We have, this counts as 1 piece because it's all underneath the square root. And so 2 pieces. So natural log, I have 2 of them. Radical 3x, I'll put this in parentheses just to make it look prettier. That's on the top, so it's positive. You can put a plus sign there if you want. You don't have to. It looks weird if you do. 7 is on the bottom, so let's make that's a minus. And then remember that radicals are just exponential fractions. So this really is the natural log of 3x minus 5 to the 1/2 power. And then you can bring that 1/2 power to the front. And then cross that out. So it's 1/2 natural log of 3x minus 5 minus 7. So in this case, you do need to put parentheses. If you don't put parentheses on it, then people will assume that it's natural log of 3x minus 5. Right? So you make sure you do parentheses on these ones to show that they are together. And then lastly, this is a very similar problem to your homework problem. I have 1 piece here and I have 2 pieces here. And then I also have this radical that goes above everything. So there's a couple ways to do this. So if I treat this radical as a 1/2 power again, okay, if I take this radical and I call it the 1/2 power, then I can use my power rule and I can bring that 1/2 to the front. And this 1/2 is going to impact everything. I have my x squared, and I have my natural log of x plus 2. So I went ahead and I split them up inside. Right, I went ahead and I make this one its own, and I make this one its own. And then I can redistribute this negative 1/2, or before that, let me bring this 2 out front. And I can distribute this here, and I can redistribute this over here. So I get 1/2 times 2, which is just natural log of x, and then 1/2, that's 1/2 natural log of x plus 2. All right, these reduces to 1. So I recommend you taking out that if this is included in everything, take that out first. It makes your life easier. So condensing. Condensing is when you bring more than one log back together to become one. So my rule of thumb, when you're condensing, you always only will have one log and the giant parentheses. And what do we have? Well, let's reverse engineer everything we just did. So this power is going to come back here. So we have x to the 1/2 power. This 3 is going to come back here. So we have x plus 1 to the 3rd power. And let's just make it prettier. You can put a multiplication sign there if you want. You don't have to. So this is the square root of x times x plus 1 to the 3rd power. So it could be real quick. So it's going to be a natural log. Again, you're going to have 1. This 2 is going to come back. So that's x plus 2 squared. This is a minus. So it's a division, and then x on the bottom. And then that's it. And let's do 72 before we go to C. So here's what I was talking about. The book makes it really difficult. If you just follow my rule, it's always going to be easy. Let's look at x, or this first one. Let's not even worry about that 3 first. This is positive because there's no negative. So it's positive, so it's on top. This is positive, so it's on top. This is negative, so z's on the bottom. And then just put your exponents. 3, 1/4, 4. And then let's make it prettier. Log base 3, x to the 3rd power, 4th power, 4th root of y, and then z to the 4th. Just remember that this is the same thing as 1/2. If there's a 3rd root, this is the same thing as 1/3. Let's say if it's 3x squared, this is the same thing as x to the 2/3, right? This power is that one, that root is the fraction. And then lastly, c. So this 1/3 is going to impact it in a little bit. Let's just keep it out here for now. And then you have log base 2. And then x times x plus 1. And then when you bring that 1/3 power back, it hits them both, right? It's going to hit them both. All it's going to do is it's just going to create a 3rd root. So just keep it simple. Just watch what the problem's asking you. Expanding, take 1 and make it more than 1. Condensing, take more than 1 and make it into 1. But just keep it simple. I think 72 is one of the best examples. If it's positive, it's on top. If it's negative, it's on the bottom. So that's really all it is.